Hello. So, in life, there are going to be lots of experts on different things. There are going to be people who tell you that they can predict what the weather will be for the next day. There will be people who tell you they can predict whether a stock will go up or down. And not only are experts people, but experts can also be algorithms, where a company might say their algorithm can make a prediction about weather or stock. The question is who to trust? Well, it turns out you don't have to trust anybody. We can use something called the weighted majority algorithm to take the predictions of many experts and start making our own predictions such that we're not doing much worse than the experts. Later, but not in this video, I can talk about optimizations of the weighted majority algorithm that allow us to do much, much better. I hope you enjoy this video. To understand this algorithm, we're going to follow along with lecture notes by Sanjeev Arora. These lecture notes are publicly available, and I will include the link in the description. In particular, I will be focusing on this first section, the weighted majority algorithm. But this paper does include more stuff, such as the randomized version of the weighted majority algorithm, and the multiplicative weights algorithm as well. These second two algorithms I won't be covering in this video, but I may cover it in a future video. All right, so let me explain the problem setting. Let's say you are a person who wants to invest in Tesla. So we're looking at the Tesla stock. In particular, what you want to do is you want to predict each day whether the stock price is going to go up or down. So each day, day 1, day 2, day 3, day 4, you want to make a prediction. You want to predict, for example, day 1, if the stock price is going to go up. Predict day 2, the stock price will go down. Day 3, day 4. So each day you want to make a prediction. What advantage does this give to you? Well, if your predictions are good, and you predict, for example, the stock price is going to go up on a day, then what you can do is you can buy more Tesla shares at the beginning of the day, and then the price will go up, and then you could sell the shares and make a profit. Now, how are you going to make these predictions, though? You could go the hard way, where you could read news. You could look at historical trends. But there is an easier way. What you could do is you could look to experts and use them to help make your predictions. Now, what is an expert? So, an expert can either be a human or it can be an algorithm. And effectively, an expert really is just a person or thing that is just making predictions. Now, the term expert is a little bit misleading because let's say we had a person who made wrong predictions every day. That person is also an expert. So an expert is just a person who makes predictions. Now, our goal is to use these experts to help us make our predictions. Let's say we had a pool of experts. Let's draw some experts. We have another expert. We have more experts. How many experts? Let's denote that number with n. So we have 1, 2, n experts. And each of them every day also makes predictions. So we have expert 1, expert 2, and so on. And each of them every day also makes a prediction. They say something like, oh, I think the stock for Tesla is going to go up. I think the stock is going to go down this day. It's going to go up, it's going to go down. Expert 2 might be like, oh, it goes down, it goes down, it goes up, it goes up. Now, our goal is to use these predictions in order to make our prediction such that we're not doing too bad ourselves. Okay, so let's get into the weighted majority algorithm, which we can abbreviate as WMA. So in this algorithm, we have a symbol n, and n is set to some number less than or equal to 1/2. So for example, we can set this number to be 1/4. And then we have our experts. Let me redraw our experts. And we have n of them. And what we want to do is associate each with a symbol. So for example, we'll do W1, W2, all the way to Wn. And this symbol is called a weight, in the sense that we're going to assign numbers to the symbol, and this symbol will basically represent the weight or influence of the expert's prediction on our prediction. So let's start by setting all these weights initially to 1. This will be 1, this will be 1, this will be 1. So let's start with day 1. So each of these experts, they're going to make a prediction about whether or not the Tesla stock is going to go up on day 1. So they all make their predictions. Let's say expert 1 predicts it's going to go up, expert 2 predicts it's going to go up, and the nth expert, he predicts it's actually going to go down. Now what we do is we make our prediction based upon these predictions. In particular, what we do is we look at the two possibilities. There's the possibility that the stock price goes up, and the other possibility that the stock price goes down. What we do is we basically look at all of the experts who said that the stock price is going to go up, and we add their weights together. So for example, let's say, in this case, let's think of n as 5. And let's say the first 3 experts all said the stock price is going to go up. So that means their weights added together is going to be 3. And let's say the last 2, they said the stock price, it's actually going to go down. So then the sum of that is 2. And then what we do is our prediction is simply the higher number. So for example, this number was higher. So what we do is we make this prediction. So our prediction is that the stock price is going to go up. Now what we do is we see what actually happened. And let's say what actually happened is this. Let's say that the stock price actually went down. So our prediction was wrong. What we want to do is for all of the experts who made a wrong prediction, we want to change their weights. So we're saying the fourth and fifth expert, they kind of made wrong predictions. And so how are we going to change their weight? So let's take expert 5 here, who made a wrong prediction. And right now, his weight is 1. What we want to do is we are going to use this parameter n we have here in order to update his weight. In particular, we're going to take his weight and we're going to multiply it by 1 minus n. And that is going to be this new weight right over here. So for example, in this case, W5 was originally 1, and 1 minus n, which in this case is 1/4, is 3/4. And so the new number we assign to W5 is 3/4. So that is the new weight of our guy. His new weight is equal to 3/4. And we do this for all of the experts who made a mistake. And we just repeat. So in day 2, we're just going to look at the predictions of all the experts, and we're going to add up the weights of the experts who predicted up and add up the weights of the experts who predicted down. We're going to sum up those weights and make our prediction based upon whatever the largest number is. And then we're going to update all of the experts that made a wrong prediction. All right, so hopefully you now understand the weighted majority algorithm. Now let's try to understand, well, how many mistakes is the weighted majority algorithm going to make us have? Hopefully, we only make a small number of mistakes in order to make the best predictions. So let's look into that. The formula is covered right over here, and I'll explain it in simple terms. So we're looking at, let's say, the Tesla stock, and we're making predictions every day, one by one. Now we have n experts, and let's say that we are looking after some number of days. Let's say that number of days, we will call it t. So for example, if we're looking at after 1 day or looking after 2 days, t would be 1 or t would be 2. And in particular, we want to look at or want to consider the number of mistakes we have made after t days have passed. So let's just call that m of t. So for example, let's say t was 2 days, then m of t is basically telling us how many mistakes we made after 2 days. We're not considering the third day, like whether or not we got it right or wrong on the third day. And yeah, so let's continue. We also, remember, have our parameter n, or symbol n, that we set. This was basically within our algorithm we set. And one last terminology we want to know is we have the number of mistakes that we made after t days, but we also want to represent the number of mistakes that the experts make after t days. So we'll just use a lowercase m, and this will be for expert 1. This is the number of mistakes he makes after t days. For expert 2, this is the number of mistakes, and so on. And this is actually going to be really helpful to us because we can focus on the expert that made the fewest mistakes, the best expert. And we can use that to help us understand how good our algorithm is doing. Okay, so we are trying to we want to find an upper bound on the number of mistakes that we made after t days using the weighted majority algorithm. So we need to find kind of an upper bound for this. So what's the upper bound for this? Well, the paper tells us that it is this. M of t, it is upper bounded by 2 times 1 plus n. And here we're going to put mi of t. Now, you might be confused, why is there an I here? Well, the interesting thing is that any of these values can be substituted in place of here. So you can set I to be 1, and this upper bound works. You can set I to be 2, you can set I to be 3. All of these upper bounds will work. So that's why I put the I right there. And then plus 2, the natural log of n over n, like that. And I've been calling this n, but really it is a symbol called eta. I was just saying n for simplicity, but now that we have 2 n's, it may actually become confusing. So this is the expression. And what we'll do is we will plug in some real numbers later and visualize in a graphing calculator like Desmos to actually see really how many mistakes we are going to make in different scenarios. But one thing to notice here is this thing, mi of t. Well, as I said before, you can place anything here. You can place m1 of t or m2 of t. You can place anything you want there. So in particular, what we could do is we could do this. We could take the minimum of m1 of t, m2 of t, and mn of t, and we could assign something like m star of t. We could assign that to be this minimum, and we can sort of plug that in for here, and this will hold. So effectively, we are bounding the number of mistakes by the best expert. All right, so now let's take a look at some real values plugged in to get a better understanding. Okay, so I basically took that formula expression we wrote from before and kind of put it in Desmos so we can take a look at some particular values. I replaced eta with p so that we can actually have n as a separate symbol. So let's take a look at this. So this is a bound on the number of mistakes we're going to make. Now, what I represented here is the scenario where 100 days have passed. And we want to figure out what is the maximum number of mistakes we can make with our algorithm. So we can set p to be any number between 0 and 1 half. So in this case, we can try setting it to 0.4 maybe, or 423. And m is going to be, well, it's going to be the number of mistakes made by the best expert. So let's say so far, over the 100 days, the best expert made only 20 mistakes. Let's say 21. And how many experts we have? Let's just say we have maybe 20 experts. So here's something pretty cool. Over the 100 days, then based on our algorithm, we will at most make 73 mistakes. No more than this. This is a strict upper bound. Now, this may seem like a lot, and it kind of is, kind of because this expression over here has a 2 multiplied by this number of maximum mistakes that the best expert could make. Because of that, this number can end up being high, and in later versions of the weighted majority algorithm, we are actually able to reduce the number of mistakes and reduce that upper bound significantly. But at least for the simple weighted majority algorithm, the bound is quite high. But we can sort of explore this. It's pretty cool that with the weighted majority algorithm, we know at most 73 mistakes we'll make. We will never make 80 mistakes or 90 mistakes with these settings, which is pretty cool. And we're bounded by the best expert, not just any expert, but the expert that makes the lowest amount of mistakes. And we can even sort of play around here. For example, this parameter is something we can vary, and we can see different values. We can actually set it, replace this p with an x and an x, so we can actually see this right over here. And we can see from this point to this point, this is 0 all the way to 0.5. So we can see that effectively we can minimize the number of mistakes if our parameter was set to effectively this value right over here, 0.377696. So we sort of set it to this, 0.377, approximately there. We can minimize our number of mistakes to be 73. All right, so that's the weighted majority algorithm. I hope you enjoyed this video, and I'll plan to cover future versions of the weighted majority algorithm in future videos. All right, thank you.